Hey everybody, welcome back. We're talking about ellipses today. This is part one. An ellipse is a conic section, just like the parabola and the hyperbola. Mostly we're going to look at equations and parts of an ellipse. We have seen general conic form. That is a form that would be for all three conic sections. And what we want to do is eliminate the rotational term. If we rotated it just a little bit, that would create a pretty complicated situation, and we're going to eliminate that for now. So we're going to take the bxy term out. We want to get this down to just an ellipse. We know if we eliminate y squared or x squared, then it would be a parabola. So we're going to keep them both. So let's give the coefficient specific values. Both of these are ellipses. Let's just look at some of the characteristics. You have both x squared and y squared, and they're both positive here and both negative there, but on the same side of the equal sign. You have to be very, very careful about that. There are some issues with the constant that we will go over later, but for now, we're just going to say both x and y are squared, and they're the same sign on the same side of the equal sign. Identify how many of those are ellipses. There are two. This one is tricky because if you move that over, it would become negative on the same side with y squared, and that would not be an ellipse. This is a parabola. That is not an ellipse. Parabola, parabola, parabola. A lot of parabolas there, darn. All right, number two, let's play that same game. See how many ellipses there are. I'm getting 5. This one is a parabola, so it's out. Please don't make fun of Mr. Linear up here. He didn't mean anything by it. And when you move that over, it becomes negative, and that's not an ellipse. Let's look at the definition of an ellipse. It's the set of all points such that the sum of its distances from two fixed points is constant. What? Well, let's investigate that. I mean, this is math class. The set of all points refers to the ellipse itself, and the two fixed points refers to the foci. I want to stop there and say that there are two pronunciations of foci. There's an American and English pronunciation, and we're going to let Google tell us that.
Foci. 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 Foci.
Well, since I live in Georgia, and that's the one by Florida, not the one by Russia, I'm going to call the plural of focus foci. The sum of its distances is constant. That means any point on the ellipse, if you connect it to both foci, that distance remains constant. We're going to look at two demonstrations. The first one is for effect, and then the second one will give us the definition of an ellipse. This ellipse is for effect only. C is a focus, B is not a focus, that's the effect, and A is just some random point on the ellipse. We have measured AC, AB, and their sum. I want to turn our attention to this sum as we move point A around the ellipse. Notice how this sum changed. When we move point B over to become a focus, it won't change. And I got to tell you, that's going to be phenomenal. Okay, B has moved over to become a focus. B and C are both foci. A is still some random point, and we still have measured AB, AC, and their sum. All right, so let's move point A around, and look how the sum stays constant. It stays 20. I got to tell you, that's fantastic. That keeps me up at night when I think about it. But that's the definition of an ellipse. Now, this thing really becomes interesting when A swings over here and becomes collinear with B and C. It's on an axis. And also when it is right here and both, let's see if I can do this. Yes, A and C are equivalent in length. Then the ellipse becomes very, very interesting, and we just get excited. We just said that when random point A rotates down and becomes collinear with the foci, something special happens, something that we like a lot. And what is it? There are two segments here, and one of the segments can be moved over here to fill in that whole axis. And that constant distance that we're talking about that defines an ellipse is the length of the major axis. I mean, wow, can you believe that? And for now, we're just going to say that it's equal to 2a. There's a reason. We'll get into that as time goes on. And then we call that point something special. Well, this is math. It's not too special. Major axis, endpoint, or vertex. Moving on. Well, what do you think that point is called? Center. Nothing special. The center does allow us to say that these two segments are equal in length, the distance from the center to each focus. And also, these distances are equal in length, the distance from center to vertex or major axis endpoint. A lot of vocabulary here. We like vocabulary. Here we can make some more assumptions. I mean, the more assumptions that we can make, the better off we are. Remember when this random point A was above the center? That these segments were both 10 in our model. Well, they're going to be equal in all ellipses, which is fantastic. And the assumptions that we can make, the segments are equal, and each of these is half the major axis. That's a big deal. Such a big deal that we love it. This segment is called the minor axis, and the minor axis is of length 2b. Well, if we cut it in half, they're each equal to b, and the center does cut it in half, just like it did the other segments. That was fun. Let's move on. All right, so it follows that these points are called minor axis endpoints or vertices. We've learned a lot. We've made a lot of assumptions. We need to make one more, that the distance from center to major axis endpoint is equivalent to the distance from minor axis endpoint to focus. In other words, all 6 of these segments are equivalent in length. If you have trouble seeing colors, I'm making them fly for you because I care. All right, all of them are equivalent to each other. We're going to call them all A, which is 1/2 the major axis. I mean, wow. Moving on. Let's review. We are calling that segment right there in this triangle, the hypotenuse, half the major axis, and we're calling it A. We're calling that leg of the right triangle B, and we're going to call this leg, which we really haven't named up until now, we're going to call it C, the distance from the center to a focus. We're going to call that C, and that gives us a Pythagorean relationship where A is the hypotenuse. Now, if you need C to be the hypotenuse, you might want to walk around the block for a minute, pause the video, walk around the block, come back, and understand that A is going to be the hypotenuse. And we're going to use this Pythagorean relationship to make an equation. We have reset up the ellipse with random point B with random coordinates X, Y. F2 and F1 are each a focus with a center at the origin. That allows us to write the coordinates of F1 as C0. If you don't get that, hit me with a text. F2 is negative C0. So if we did the distance from F2 to B in the distance formula, it would look like that. And similarly, if we did F1 to B, it would look like that. Now, those distances are not equal, but we now know that they add to be a constant, and that constant is the major axis 2A. Now, I'm going to do a whole lot of algebra here without narrating it. If you want it narrated so that you can understand that, it's going to be linked to another video, and you'll have to go watch that. So I'm just going to populate the boxes, and you can pause the video and look at what I have. You may want to do that. You may want to figure this stuff out yourself. That would make you an all-time great or a top hitter in the league. Again, a bunch of algebra. I'm just populating the boxes. These are the steps. Doing it kind of slow. That's actually b squared right there. It's a little bit of a hint. And ultimately, we get down to this equation right here. That is an equation of an ellipse with only A and B in it, where A is half the major axis and B is half the minor axis. I mean, that is fantastic. This is called standard form. And what we will do later is we will move the center around with the HK thing like we did the parabola. That's called translating. Isn't math great? All right, it's worth noting that when we came up with this equation, which is just great, we started with a horizontal ellipse. So let's distinguish kind of the last thing we're doing here is distinguishing between horizontal and vertical ellipses. Horizontal ellipses are of this form where half the major axis is under the horizontal variable, and vertical ellipses are in this form where half the major axis is under the vertical variable. We haven't done a whole lot of problems today. Keep in mind at Socrative, if I'm talking about number 3, that's what I mean. Now, right here, we're trying to determine if an ellipse is horizontal or vertical, and we want to associate it with the letter A. A is necessarily bigger than B. 10 is bigger than 4, and since 10 is under the vertical variable, it's a vertical ellipse. It's really that simple in a problem like that. Number 4, you should recognize this is a parabola because y isn't squared. Let's move on from that. Number 5, okay, this is an ellipse, and 64 is bigger than 36. 64 is under x. X is the horizontal variable, makes the answer B. Number 6, which ellipse is horizontal? So we want to look for the bigger number under x. That's the answer. You might say, well, hey, what if they're the same? Then it would be a circle, which is a special ellipse. That would be nice. Which point appears to be the focus? Let's end the day with just some simple definitions. Clearly, the foci are D and F. That looks like the answer. Let's move on. Number 8, the major axis endpoints are E and A. I believe A is present. Number 9, the center, please. No discussion. Moving on. Number 10, which segment appears to be half the minor axis? Well, the minor axis is that length, and half of it is that, and I believe BC is present as an answer. Let's move on. Which point appears to be the focus? Okay, we just made it vertical. The foci are R and X. I believe X is present. I think we only have 2 more problems, which absolutely makes me sad because this has been great. All right, which is equal to A? By definition, A is half the major axis, which is TQ or QY, and I believe QY is present. But, it can be tricky. Last problem of the day, which is A or half the major axis. There are 6 segments in the ellipse that are equal to A or half the major axis. It's just which one is present, and I believe it's that one, XS, right here. Guys, I had a whole lot of fun talking about ellipses with you today. I can't wait for part 2.